Hello, everyone. I welcome all on Data Phoenix webinar. Today we will speak about cost optimization for the inference, how you can reduce your cost for NLP LLMs models. Together with us, Meryem Arik. She is co-founder of TitanML. And she will talk about how you can optimize your cost. You can ask the question on Slander. The links you can find under the video. So after the presentation, we will ask for all your questions. So Meryem, your microphone.
Hiya. Thank you everyone for joining. Good morning if you're based in the States. Good evening if you're here with me in Europe. I'm in London. It's very lovely to be here. So thank you so much, Dimitro, for the invite. So today I'm going to be talking about inference optimization. So in the title, I was actually called it cost optimization, but I'm actually going to make it a little bit broader. And what I'm going to talk about today is building production-ready LLMs for specialization. So this includes cost, but it also includes things like latency and other things. So hopefully you won't be too disappointed by the slight change of title. So in AI, there's a saying that goes around, which is it's really easy to build a demo, but really hard to build a product. And this is something that we've seen increasingly with the emergence of APIs like OpenAI. It's very, very easy to get something working, but people who've done the last mile, which actually isn't very many people yet, have found it very, very difficult. And this is the problem that I'm going to be talking about today. So as a brief introduction, I'm Meryem. I'm a co-founder of TitanML. My academic background is in theoretical physics and philosophy. I have a particular love of ethics and philosophy of mind. If you want to geek out with me, huge fan of dogs, rugby, and Christmas. They're my three favorite things. And you can follow me. I just created a Threads account, so follow me on Threads. And also, I'm pretty active on LinkedIn, so give me a follow on LinkedIn, and you can hear more about the kinds of topics we're going to be discussing today. So the agenda, what are we going to be going through today? So I kind of gave it away at the beginning. The first thing is that base models, so when I say base models, you could interpret these as foundation models, are not the same as finished products. That's the first thing we're going to talk about. I'm then going to talk about this concept of specialization. So although you might not have heard of the word specialization, you probably would have heard about the techniques that I'm talking about. And I'm going to talk about how this is so crucial to building production-ready LLMs. And then finally, I'm going to give you, tell you a bit more about how you can build production-ready LLMs using specialization. So main takeaways from today will be building production-ready LLMs is not easy at all, but specialization for task and deployment is really key in that process. So we have the open source community and the closed source community have blessed us with a huge number of base LLMs. So on the closed source side, we have things like GPT-3 and 4 from OpenAI. And on the open source side, we have great models like BERT and FLANS and llamas and falcons. And these are really, really highly performant models. But these are not the same as finished products. There is a really big gulf between them. Now, when a lot of people talk about finished products, they talk about finished products in two senses, and I'm going to briefly mention both of them. The first sense is a product that a user can use, and the second sense is like a production-ready, a product-ready LLM, and that's what I'm going to focus on. But very briefly, I'm going to talk about why it's not a finished product in itself. So if I have a base model, like if I take the easiest path to using AI, which is using something like OpenAI, that is really, really different from a product. So an example I'm going to use is a company called AutoGen AI. So these are a really fantastic example of how you can use these base models to build a great product. So what they actually do is they use AI to help bid writers, so people who are tendering for government contracts and that kind of thing. And what they have done is they've taken base models and turned it into a product, but through a lot of hard work. So they've wrapped it around fantastic UI, domain specificity, and then really smart interaction with the AI, helping you prompt all of these things. So it's not an easy journey to get from a base model to a final product. Like AutoGen, I know these guys, they worked really, really hard to get to this point, to a product that users really love. So I'm going to set myself a slightly easier challenge of how do I get models to just like a product ready model. So still not looking at UI, not looking at anything of that, just looking at the AI part. So even if we focus just on the model, these base models are not these product ready models. Why? Okay, well, I'll give you two main reasons. The first one is that they're probably not that good at the task you want to get them to do. So there's this paper that was released earlier this year. It's called ChatGPT, Jack of all trades, master of none, which is this idea that although ChatGPT is fantastic and has really impressive general knowledge, it doesn't actually hold state of the art in very many things. And that's because, you know, when you can build a model or fine tune a model just for your task, it ends up being much, much better. I can, you know, this is just one example, but in the enterprise, what we find is that base models really don't cut the mustard on their own, because there might be business or industry specific terminology that you want to use that the base model doesn't have. Other things that you know, your base model might not have is like tone of voice. Let's say I'm Innocent Smoothies in the UK that has a very friendly tone of voice. My base model might not be able to get to that even with prompting. The second reason, so that's, you know, base models are not product ready. One reason for that is like they just might not have the accuracy or the quality that you need. But the second reason is that they might not match your deployment environment. So when we build a product, we have a whole bunch of things in mind of what we need that product to do. So for example, if I'm building a chatbot, I need my latency to be really good because I want it to be a real-time conversation. So latency is a key issue. Let's say I'm building something that I want to deploy at really, really mass scale, then unit economics matters. I might have certain restrictions with hardware if I want to run it on laptop versus like in a big cloud. Other people are starting to think about security. So whether they want to be sending their data to OpenAI or whether they want to run it in-house. And also scalability is an issue. So I need a model that I can run at high scale. And very rarely do models come out of the box perfectly fitting for whatever deployment environment you need to put them in. So we need to do a bit of work of specialization because of this. So the way that I would describe this first point is that we want to get to our final product, and our final product is our Statue of David, right? It's this beautiful crafted work of art. But the base models are more like our block of marble. They're a necessary but not sufficient condition to get us to that product state. But we still need to do a lot of work and a lot of craftsmanship to get from one to the other. So the second point that I wanted to talk about is that if base models are not product ready LLMs, how do we get there? Well, the answer that I'll propose is this concept of specialization. So I think about specialization in two distinct ways. I have my task specialization and my deployment specialization. And these directly map onto the problems that I talked about in the last part. Task specialization is how do I get my model to perform really well for whatever I want it to do? And deployment specialization is how do I get my model to fit my latency, my hardware, my cost requirements that I need? And once I have both of those together, where it performs really well and it's, you know, I can deploy it in the way that I want to, I have a deployment ready LLM. Not quite the finished product, but it's, you know, deployment ready that we can get a fantastic product built around it. So let's start with task specialization. So this encompasses a bunch of different methods at different parts of the development process. So I'm gonna broadly abstract task specialization into like three types of, you know, models. The first one is your generic language model. So this is what I was talking about at the beginning with your base models, your foundation models, your generic language models. And what these models are really good at is just like broad and general language understanding. These models have been trained on the entire internet twice over, so have really good understanding of just how language works. The second type is like this industry-specific language model. And we're starting to see more of these, and I reckon we'll see more over the next, coming months and years. So Bloomberg GPT is an example that came out earlier this year, which is a language model which has been trained for finance, not for a particular task in finance, but like on financial data. So it has really good understanding of financial, lingo. For example, if I say a bear market, it's not going to think that I'm shopping for bears. And there's this so that is our generic language model, our industry-specific language model. Now, typically, as an enterprise, as a business, as a practitioner, I don't have to make either of these. The generic language models are made by your Facebooks and your, Metas and your Googles and your, really large tech companies. The industry-specific language models are typically made by research institutions or really large businesses. But for most enterprise use cases, you're looking at a task-specific language model. So this is a language model that you're building to solve a particular task in your organization. And this is by far the most common process. And there are a bunch of things that we can do to build models that are task-specific. So one that I'm sure you might have heard of is prompt engineering. So this is the process that we use when we talk to ChatGPT and try to get it to do the thing that we want to do. And you can do cool things here like, do prompt injection and all kinds of interesting things. There's RLHF, which is the process of reinforcement learning with the human feedback. I put this here for completeness, but it's not actually something I've ever seen an enterprise do. And then fine-tuning, which is by far the most common process that I've seen for enterprise use cases. So this process of fine-tuning is you get a relatively small amount of high-quality data that you want your model to be able to emulate or act in that kind of way. And this will be very, very task-specific. And this is very, very effective in getting models to learn like tone and getting it to, answer in the way that you want to respond. So what's magical about this specialization is there are two things. Firstly, it makes models much better. So given that I have a fixed size in model, my model will typically perform much, much better after I fine-tuned or specialized than before. But what's also really cool is that smaller specialized language models that have been fine-tuned on the relevant tasks often outperform much larger language models. So this is an example that I think came out at the end of last year, that FinBERT, Financial BERT, which was fine-tuned on a financial sentiment analysis task, which is one of the most common tasks that we see in the financial services, outperformed GPT-3, even, a few shot GPT-3, which is really, really impressive. I'm not sure if it would be GPT-4, but considering FinBERT is maybe 100 times smaller, maybe, even more than leading OpenAI models, this is a really, really impressive result. So these specialized models are very, very high quality and also can be smaller and get similar results, which is fantastic. So one of the key challenges that we find with our customers when they're working to fine-tune models is that access to high quality labeled data sets is a real blocker for them. Fortunately, there's lots of really interesting things that you can be doing that's been that we've been working on over the last couple of years. And one of them is using synthetic or augmented data to make fine-tuning much, much easier and cheaper. So what I've drawn out here is a typical development cycle that we see when people are building language models in the enterprise. They will typically use a large language model to prompt and get a very, very good first demo. And this will typically take a couple of days. And then they'll use a language model to produce these high quality labeled data sets to fine-tune smaller models. And these are much easier to productionize and actually get a product out of it. If you're interested, you can read more. We wrote a blog about this a couple months ago called GP Teacher, which was using a large language model to create a data set to train a smaller model on. And we actually managed to match the performance of gold standard labeled data sets, which is really cool. And it took us, I think, only a couple hours to do that, which is a massive boost compared to hand labeled data sets. So that is task specialization. So that's the process of turning this base model into a model that performs really well for your task. The second kind of specialization I want to talk about is deployment specialization. So this is the process of ensuring that your model runs with the latency required on the hardware of choice. The reason why I'm focusing on latency and hardware is typically if you've got that, everything else comes for free. If I have it running at a good latency on my hardware of choice, that looks after cost, that looks after user experience, that looks after security. So, those are the two key factors. And I'll actually show you a demonstration now of what it looks like with and without deployment specialization. So let's say that we are building an enterprise chatbot. We're going to use the Falcon 7 billion parameter model. And for whatever reason, maybe we need to deploy it on a particular CPU. That might be because we can't get access to GPUs. It might be because of cost restrictions. It might be because we want to run it locally on our laptops. But let's say we're aiming for a CPU deployment. And we also have the requirement that it needs to be real time. So I need something that can inference, super, super quickly while I'm reading it. So the video I'm going to show you is a demonstration we actually released yesterday, so very, very new, of us doing a Falcon 7B, inferencing a Falcon 7B on a CPU, one with and one without deployment specialization. So the one on the left, let me get up. So the one on the left is without, and the one on the right is with deployment specialization. So we've asked it what are fun things to do in London. You can see the TitanML server is whirring away. It's telling me to go to the Tower of London and go on the London Eye. I mean, fairly touristy. And the other one gets to, let's play that again. The other one, I don't even think writes more than 2 words. So this one's whizzing away, and without, I'm still waiting. So if you don't do this process, it literally makes it impossible for you to hit, there we go, we have 1 word, hit your required latency on your required hardware. So that's why this is such a crucial process. If you are interested in trying this out, let me know after. We will be releasing it onto our beta platform in the next week or so. Okay. So what are the various techniques you can use in this? There are a bunch, but here's just a couple. Quantization is a very well-known one. So that's the process of replacing floating points with integers. Knowledge distillation is one that we are a big fan of, especially for natural language understanding tasks like BERTs, where you can get larger models to teach smaller models. Pruning, early exiting, there's a whole bunch of techniques that you can do in this deployment optimization space. And this can lead to really radical reductions in inference costs. So let me give you an example that we did with a client. So this particular client was running like a neural search for financial documents. And in order for them to achieve the latency that they required, because they wanted this to be real time, and with the accuracy they wanted, so they had a model that worked really well, they needed to deploy it on 2 A100s. That was the way that they could get the latency they required. However, we came in, we did a whole bunch of optimizations. I think it was a 10x reduction in size, 7 or 8x reduction in latency. We were able to move this model from inferencing on 2 A100s to inferencing on a much cheaper GPU, a T4, and you could get a 96% cost reduction with that, which is pretty transformational. Like that is a 20x reduction in cost, which is transformational for unit economics of these products. So I've put together a very sketch-like version of kind of how I would build these LLM products depending on where I am in the life cycle. And this graphic is actually inspired by Alex Ratner from Snorkel AI. So on the x-axis, we have the difference between prototype and production. So there's a really, really big difference of, am I seeing if this can even work, which is your prototype, and your production, which is this works, I need this to inference, and generic and bespoke. So what is the use case that I'm working towards? Am I building a generic chatbot that's just gonna have a conversation with me? Or am I building something that's gonna be able to like, predict the next COVID vaccine? I don't know if that's even possible yet, but for example. So where we always recommend people to start is if they're building something that's fairly generic and they're prototyping, so they're just seeing what's possible, they're playing around, we say use out-of-the-box AI. And typically this is the OpenAI API. You can get things working really, really quickly here. What we say to our clients is if you can get it running on the OpenAI API, we can get it running on an open source model. This is a really good way to test what is possible with these kinds of models. Now, let's say you want to build either something, let's start over here. So production, a generic model, so not doing anything super fancy, but I want to get it productionized. There are two things that you need to focus on. The first one, even though it wasn't the top of the talk, is to really focus on the UI, because you don't have a model moat. You need to have a fantastic UI and a fantastic customer experience. And then you also need to focus on the inference optimization. So one issue that we often get with the OpenAI API is that it doesn't have particularly high rate limits. So maybe I want to build a generic in-house model where I can really optimize the inference. So that's something to consider. The other alternative is either bespoke, but I'm, bespoke data, bespoke knowledge, but I'm prototyping. Typically, you can do this with prompt injection or prompt engineering using API-based models. We haven't actually worked with many people who sit in this category yet. But by far, the most common thing that we do see is enterprises. And enterprises want to build bespoke and productionized models. They want to build models that are bespoke for their tasks, their companies, their industries, that can run at scale and that can really solve their problem in like a non-hacky way. Most enterprise applications sit here, and my kind of secret recipe or suggested recipe for most of these is a combination of fine-tuning and inference optimization. So between the two of these, you can almost always get really, really good results out of this. So this is kind of like a bit of a cheat sheet, depending on where you sit in the process. We almost always say 0 to 1, just use an API-based model. But when you're looking to build something bespoke or productionized, you really need to start thinking about how can I make sure this model is really high quality and can run at scale. I've talked a lot about this process of specialization, but this process can be fairly difficult and expensive. It's not the easiest process in the world. That's what we work on. So what we spend our time thinking about is how can we make it as easy to get to products as it is to get to demos. We're trying to close that gap. So if I kind of split the kind of things we work on between task specialization on the left and deployment specialization on the right, for task specialization, we love fine-tuning. So we host infrastructure for fine-tuning using like state-of-the-art techniques such as QLoRa. And we've also done dataset generation and dataset augmentation to help people build high-quality, fine-tuned, specialized models quickly. And then the second pillar is this deployment specialization. So given that you have a model, how can we get that model into deployment as best as we can? So a combination of things like model compression, quantization, efficient runtime is the kind of things that we think about from a deployment specialization point of view. So as you saw the Falcon example before, if you want to get something running on a CPU, this kind of infrastructure is the kind of thing that we work with. And our clients have seen a bunch of benefits, like, you can end up with much, much, much cheaper deployments. So typically we see between 90 and 95% model inference cost savings, which is pretty impressive. We can get much better models as well for a given resource budget. Faster models as well. So typically we see about 50 to 100 times speed ups. And we also see like much easier developments as well. Like setting up this infrastructure is one of the hardest parts of building these models. So, you know, if we can automate as much of that as possible, that's a massive bonus for us. So key takeaways. Building AI products is really, really hard, and work needs to be done to get these models into production. To get the highest performance, you do need to be looking at task specialization. If access to data is an issue, you can use synthetic and generated fine-tuning data. If you are just prototyping, use API-based models. That's what we always suggest. Fine-tuning and inference optimization is a really, really good recipe for enterprise applications. And we help you build deployment-ready LLMs. So I put 2 QR codes on the screen. The one on the left is to join the TitanML beta program. This has a small number of the techniques that I talked about today, and it's for ML engineers, so people who want to build and deploy these things. And then if you're at any other stage in the LLM development cycle, let's chat. So the QR code on the right, scan that, and we can book in a conversation and talk about the kinds of things you're working on, and if we can help in any way. If not, we'll just have a nice chat over a cup of tea. Yeah, super lovely to chat. Do we have any questions?
Yeah, thank you for your presentation. It was very interesting. Yeah, you can ask the question on the Slander. I will share, yeah, the Slander. You can scan this QR code and go to the Slander page or find the link under the video and ask the question, and we will see your question on the screen and answer for it. Oh, we have first question.
Great question. So the question is, when you're doing hardware optimizations for inference, I think that's what it is there any compromise on the quality of the results? So that's a fantastic question. Sorry. For some optimizations, yes. For some, no. And the better you are at doing these things, the less degradation you see. So I'll kind of separate them into 2 buckets. So things like pruning, and you know, when you're actually turning a model into a smaller model, like compression, you very often see like some compromise on the accuracy of results. However, if you're good at optimizing these models, what you tend to see is that the quality of results kind of goes down in line with like the Pareto front. So it'll still be hopefully better than if you started with models of that size, hopefully. So if you have a given resource budget, the hope is that it will be better than if you started at that size, or typically it is. And there are other optimizations that you can do, things like great runtime engines or quantization, where there is slight compromise, but I mean, barely noticeable. So we kind of call those like near enough lossless optimizations. Hope that answers the question.
Any more questions? Okay, if we will not have, okay, we have one question.
So the follow-up question is how to measure the loss in quality. This is a difficult problem in natural language generation, especially because it's very hard to say like what good looks like. The best way that I've seen it done is essentially just like a vibe check. So to try just use the product for a number of inferences and see if the results make sense. If they still kind of make sense, then you're probably fine. That's the way that I like with generation. That's the way that I think about it. I know there are official scores, but like for me, that's the most intuitive. And then with like natural language understanding tasks, you have a bit more of a what's right and what's wrong. So that you can use that as well. What are some of the leading companies aside from TitanML in the space of lowering inference costs? How is TitanML better? So who else is in this space? So like there are a couple other companies in this space that will focus on like one particular aspect. So there are companies that focus like just on runtime engines, for example, or just on pruning, or just on synthetic data, or just on fine tuning. What we are under the one key belief that we hold is that people don't want to be going to like 10 different things and stitching them together to build a great model. So we, try and support the entire pipeline as best we can. So like for a given company, we want to end up with a really fantastic result at the end of it by layering a whole bunch of different techniques. So that's one way that we're better. The other way that we're better, well, not better, but I think we're really great, is we are very, very, very good at integrating the latest publication or the latest techniques. So, for example, when QLoRa came out, we had it integrated within about a week. So whenever there's latest research, we integrate it super, super quickly. Who are your target customers, and could you provide an example of use cases for them? So who are our target customers? So essentially enterprises that are using NLP or want to be using NLP, and each of them are at different stages in the life cycle. People who are a bit further along, what we help them with is like, okay, how can we get these models in production through, using less GPUs or for a lower cost or for a faster latency? And there are some, people that are a bit earlier on, where they're just figuring out how to build these things, and we can help them fine tune and get all the way to production. But enterprises that are using NLP, so like the kinds of companies that we work with are financial institutions, insurance companies, companies that use a lot of text. So could you tell us a bit more about GP Teacher? How does it work? How do you measure the training quality? For sure. So it's a super simple experiment, and you can look it up on our Medium blog as well. So there's we got a large language model to what's the best way to start? There is this data set called AG News, and what the data set does is it gives news articles, news headlines, and then a categorization for like if it's business, if it's science, if it's weather, if it's whatever. And that's the data set, the gold standard data set. So what we did for our control experiment is we fine-tuned I think it was an Electra model on the AG News data set. And we scored that and got the results from that. And then what we did is we got a larger language model to look at like the first 10 rows of AG News. And we say, okay, cool, produce like 10,000 more examples like this. And it produced a whole data set, completely synthetic. We didn't go in and check any of them. It just got seeded from these first 10 examples. And then we trained the same model off of this generated synthetic data set. And the results were pretty good, like comparable to what we got from the gold standard data set. And what we can conclude from that is that this process of like manually labeling, manually collecting data can be somewhat replaced or somewhat augmented by using larger language models to do that labeling and replacing for you, for example. The platform looks exciting. It's solving real problems companies facing while taking LLMs to production. Fantastic. You should message me afterwards. We can chat and make sure we're doing the same for you guys. Cool. Great question.
Yeah, I think it was very interesting question. Good. So thank you for your presentation, for your sharing knowledge, and I hope your company will growing and you will have more interesting customer. Um, so thanks for all who was with us. Please don't forget to subscribe to our YouTube channel because we are preparing a lot of very interesting webinar in August about LLMs. So subscribe to
Exciting.
us.
I'll
Yeah,
definitely be very exciting. Thank you so much
yeah,
for listening. Thank you so much for hosting as well.
yeah. And if you will have some questions, you can also find Meryem in our Slack channel, and you can follow she on LinkedIn.
Yeah, for sure. And threads. I now have threads. Well, you there as well.
Yeah, thank you for all.
Okay.
See you.
See you guys. Bye.